All right. Your midterm results are posted on ePost. Hopefully you check that. If you want to pick up the paper, I don't have them now. You can come back with me after today's class, go to my office and pick them up, or anytime next week. That's fine. Just during my office hour. All right. Let's now go back to briefly about voice safety. Right. Let's think about what voice safety really is. It's more about what used to happen in your Java program for null pointer exception at the runtime. Somehow Eiffel checks this kind of problematic scenarios at the compile time, which means if for this particular scenario in Java case, it will be a runtime null pointer exception. But in the Eiffel case, they will simply give you a compilation error. That's what voice safety is. Okay? Let's see one more example, and then we'll go over some concept, and we're done for this lecture. And then I'll go on to next topic, which will be related to your lab number 5, your final lab. Okay. Right. Let's just do another example over here. This one's slightly more interesting, I would say, okay? But kind of related to the previous 2 examples. We still have the point class over here. We got x and y attributes, and we got the point collector. And now in the constructor, we do actually initialize the array list. We do. Okay, so nothing wrong with the constructor here, I can tell you. And then let's have a look at a test and see if things might go wrong, either at the compile time or runtime. And don't forget, we are talking about Java at the moment, not Eiffel. Okay. Let's say we create a point collector object here, okay, PC, and then we have some scanner. For those of you who program in Java, you know what this scanner is, right? Just for reading some standard input from the keyboard, for example. And line number 4, we'll simply say enter integer, all right? And then we read some integer from the user, which can be anything. And then let's assume they really enter some integer. They wouldn't enter any string, okay? And we say that if the integer that the user entered is negative, then we assign PC to be null, okay? So that means we don't really assign PC to null unconditionally. We assign that only under certain circumstances. And then we say that line number 7, PC.add points, some new points. And then we'll say assert true. After adding the point into PC, we want to make sure the first point we get has x value 3, like here, and y value 4, like here. Okay? It's easy. It's not really complicated program. I can tell you the Java code over here compiles. So compilation is not an issue. If you try to execute the test number 3 over here at the runtime, can you see any problem occurring, or it's going to be just okay? Anybody? Well, it depends. Either you can say, okay, how about I'll give you 3 options here. Either you can say, no, at the runtime, there will be no null pointer exception when we execute this code. Number 1. Number 2, yes, you will definitely get it. Number 3, it depends on the input. Depends on the input. Okay, can you give me any example? If I is negative, for example, -1, right? Okay, let's make it clear. Okay, and then we'll see what happens. Okay, and then we are okay with this example here. Well, basically, I can tell you that the trick really is over here. PC is assigned to null over here, only under the circumstances where I, which was read from the user input, happens to be negative. If the user, let's say, if the user simply just enter, for example, 3, which is positive, right? Now in this case, I would be 3. 3 less than 0 would give you false, which means you don't execute this line of code. So PC remains to be not null. In that case, executing this line of code would be okay. That's the case where you don't have a null pointer exception. On the other hand, if you try another one, let's say you try -2, for example, right? In this case, if I is -2 over here, -2 less than 0 will give you true. That means you will execute this line of code, reassign PC to null. In that case, calling the next line in line number 7, PC.add point, will give you null pointer exception because the context object is null, right? So it really depends. Apparently, the Java code, the Java compiler is not able to figure out this kind of behavior. Well, this is kind of easy behavior as we can see as a programmer. But for Java compiler to really check this in general is simply undecidable. As I try to convince to you, as we learned from 2001, there are many, many problems that are simply just undecidable. You just cannot automate a solution for that, okay? Now, however, if you try to translate this Java program there to Eiffel, which I will show you, and also give you some sample code to play with, what happens in Eiffel is it does not even allow you to execute the code because it will be a compilation error. More specifically, when you try to compile the code in Eiffel, one moment, yeah. What they will do is they will simply tell you that, well, PC over here has the possibility of having the void, which means null value. That's what you will see in Eiffel. I'll show you, okay? Yes, question?
So if you're changing input to positive, then you would not have the null.
True, that's true. That's why I would say it depends. So that means, okay, how about put it this way? This fragment of code in Java has the possibility of having null pointer exception at the runtime.
If the input's correct, though, like say if it's positive, right, it would then.
Well, actually, you can see that it has nothing to do with the implementation for the code. It really depends on what's really read by the user, the clients, right? So nothing to do with supplier, okay? All right, but for Eiffel compiler, they don't even allow the how do you say? They don't even allow any chance of having the null pointer exception. If you got any possibility of null pointer exception, they wouldn't allow them to compile in Eiffel, okay? Of course, this is not supported in Java. This is not supported in C#. So how can we learn from this? I'll give you some remark at the end. Okay, let's go over some slides very quickly. The idea of voice safety is not difficult. Okay, so what we'll do is, so now what we really learned is for the Java program, if the program compiles, it doesn't really mean you're free from null pointer exception. In fact, including myself, when we write program in Java, we always write into null pointer exception, right? Unless you're really, even if you're very experienced, you always just forget, okay? Forget to check certain things. Let's admit that. Okay, so now it can be uninitialized attributes in the constructors, or it can be you try to pass some variable that can be null in the arguments, or try to call the methods on the try to call the methods on some context object that can also be null. Right. A little bit history. I don't think any one of you has ever programmed algo W. No, not myself either. Okay, it's back in 1965, and it was invented by some a researcher called Tony Hoare. Do you know who he is? Actually, I learned about his work back in 2011. Anybody? Do you know quicksort? He's the inventor for that. So Tony Hoare, he is inventor for quicksort. He invented many things. And towards the end of the semester, if you look at the syllabus, we're going to learn something called Hoare triple for verifying software formally. That's also his invention. We'll learn about that a little bit later. But anyway, so he invented this null pointers concept because it's so easy to implement. If you think about what a pointer is simply an address for somewhere in the memory. So if you have no meaningful address, it's simply just null. Okay, it's a very straightforward concept. That's why it's so straightforward to actually use as well. However, the inventor for null pointer, he admitted that it's actually a so-called billion-dollar mistake, simply because when you actually allow your program to contain null pointer, that means you can very easily to get to null pointer exception at the runtime. So it's quite what he considers a mistake. If you're interested in hearing some talk, you can simply click on the link. It's only for you some extra reference. Okay. All right, so you can read it over. I don't have to worry about it. Okay, so that means if you consider yourself undisciplined, maybe, in that case, you might very often run into null pointer exception. Okay? That means voice safety can actually be useful, or at least have the concept about voice safety. Let's see, I just want to have a very brief slides just to give you more idea about voice safety. So in Eiffel, there is a concept about detachable. So what does that mean? Okay, let me just show it to you. So when I say detachable, the concept like this, they have a special terminology here. I'll try to explain. So if I have an object, let's say ACC, that's an account object. When I say ACC is currently pointing to some valid object, let's say of type account, okay, in the memory, we say that ACC is attached. Okay, attached simply is pointing to somewhere that's meaningful. Okay. Now when we say detachable, When we say a variable is detachable, simply means somewhere in its the reference. Sorry, when we say a variable, let's say I'll give you one example. If you look at the declaration over here, ACC3 and of type account. However, we have a keyword over here called detachable. So what does that mean? You can think about declaring ACC3 in Eiffel like this way to say it's detachable. It's basically like when you say account ACC3 in Java. I'll write it down. Okay? So this is really equivalent to when you say account ACC3 in Java. Because in Java, you are not really obliged to actually always give some non-null reference to an object. It can be null, right, throughout the lifetime of the variable. So in Eiffel, if you want to say at some point of the lifetime for this particular variable, if it can be void or null, you have to say it's detachable, which means there may not be any attachment, right, throughout the lifetime. It's as easy as that. On the other hand, if you say ACC over here, another variable, I don't have detachable, I simply got a class type over here, which is pretty much what you guys have been doing. That simply means at no time during the lifetime for this particular variable can you assign void to it, or it can never become void throughout the lifetime. If you ever try to do it, then that means you're going to have some compile time error. Okay? Any questions so far? Okay. I think the only thing you have to make sure you understand is what does attach mean? And then what do I mean by detachable? And what do I mean by non-detachable? Non-detachable simply means this, you simply cannot detach the variable at any point. All right, let's do some little bit test over here, right? Let's say we got 3 variables over here. We got ACC, as we know, is non-detachable, right? We got another one, ACC2, which is also non-detachable, right? And also, we got ACC3, which is detachable. We had to declare that explicitly, which means in Eiffel, by default, every reference variable is non-detachable by default, okay? Now, let me just add one more thing to it. If I say ACC3 is assigned to ACC. Okay, now I got 3 assignments for you to consider. Just think in terms of your intuition, okay? I'm gonna number them. Let's say this is number 1, this is number 2, this is number 3. We got 3 assignments over here. Let's consider one by one. Let's say you actually got these kind of assignments somewhere in your program. I only want to ask you your intuition. Do you think they will compile or not? Okay, let's go one by one. What about line number 1? Yeah? Line number 1 is very easy because ACC over here, let's try, okay? You can think about, again, static type, although we don't have to worry about inheritance in this case. ACC was declared to be always not void. And ACC2 also is always not void. So assigning something that's not void and to something else that's not void, that's okay. Okay? Good. Following this intuition here, do you think line number 2 will actually compile? No, right? Okay, hopefully you get an idea. Let's try to illustrate in case you haven't got it. So now we are saying that ACC over here, the requirement is ACC for this particular one should always point to some ACC object, should always. However, ACC3 over here was declared as non-detachable, which means there may or may not be attached. So ACC might be simply pointing to void, meaning null. In that case, you are simply trying to assign ACC to ACC3, in which case it will violate the declaration, right? So that means this will not compile. Yes, question?
So to clarify.
Yeah.
So non-detachable means, does that mean void?
No,
Non-detachable.
not the opposite, okay? So non-detachable, well, if you think about what does detachable means, detachable simply means nullable. If that makes you feel more comfortable, that's okay. That means at no points can the variable be null. So that means,
Null means void.
yeah, null is void. No problem. So null is void. Okay, just terminology.
Got it. Thank you.
I wouldn't mind in the exam if you simply say null instead of void. That's okay by me. Okay, it's the same concept. Okay. All right, let's do a quick check. What about line number 3? We simply swap the order, right? So now we're basically saying that the source over here is always attached to something, ACC, is always attached to something. ACC3, on the other hand, may or may not, but that's okay. We're just fulfilling one of the possibilities, so it's going to point to there. Okay, guys, any questions about this? Yes?
Is there an example of a situation where we might want a variable to point to what?
Yes, there might be a situation. How about this? You can try. If you try to recall lab number 2, which, of course, I got to return your marks soon. Okay, for lab number 2, you did something about database, right? Remember, one of the features is to find the key, the key for some associated value, right? Something like that. That one you can just say is, you know what? I don't want to sketch the idea, otherwise everybody get confused. I'll try to give you some example next time. How about that? So there, the question was, can I give more concrete example about to use detachable? I'll give you one example on Tuesday. Okay? If I just sketch the idea, you might just get confused. Okay. Yes.
My question is from the previous slide, you're talking about like void and null and all this stuff.
Yeah.
For Java, compile checker, like the null checker and everything, if it's possible in Eiffel, like check for null objects in the future in runtime, in compile time.
You mean for Java compiler to adapt to Eiffel compiler?
No, kind of like if Eiffel compiler can like use null in compile time, why can't Java compiler be on this?
I think, yeah, good question. The question was, if the Eiffel compiler could do it, why did Java compiler not do it? The reason is, somehow Eiffel compiler only introduced this new feature about voice safety only a few years ago. So that's quite a new things to have. Yeah, but for Java compiler or C# compiler, just a standard compiler, what they would do. Usually they rely on you as a programmer to be disciplined enough. But we all know we may not be, right, in reality. So I would say, getting used to the voice safety concept in Eiffel, hopefully you can adapt that concept over there to when you go back to the program in C# or Java. You just always remember to initialize the attributes, and always remember before you try to call a method, make sure it really be not void or not null, right?
Oh, one quick question. Is it possible for variables to get changed around to detachable, non-detachable?
Okay, the question was, once I declare, for example, ACC3 to be detachable, can I at some point to change its static type? No. Once you declare, well, remember what we said about static type, right? Once it's declared, it cannot be changed. Okay?
Also, is it part of the static?
It's part of the static type, yeah. Oh, you mean like a casting from detachable to not detachable? No, you don't do that. Yeah, that'd be too complicated. Yeah. Think about it's an orthogonal issue here, right? We're just saying that on top of the inheritance that we talk about, sometimes the variable is just not detachable or attachable, right? Good. Okay, let's go over a little bit more slide, but this slide is done. Okay, you can go over that, the same example. So now the only thing I want to show you is, okay, let's see this. If we try to translate the program back to Eiffel, remember we talked about 3 examples in Java. So basically, I'll point to you what you should look at, okay? But it's rather boring to go over the same code for many times. The same example over here, but now we are talking about, for example, you can see over here, the make was declared to be a constructor, right? I think that's the #1 most common issue you have encountered so far as a beginner to Eiffel. We have the make to be the instructor over here, and we do have a reference type attributes. But you can see the constructor over here is simply just empty. Well, you can definitely do that in Java, but you will run into runtime exception. But in Eiffel, it will simply complain. Let me just show you very quickly, just to strengthen your impression. Let's see over here, you can download the source code. If I try to compile the example code, you'll give me a serious compilation error. And the one we are talking about, hopefully, this reads very familiar to you. It says, variable is not properly set. All right, and then for that one, attributes, for example, points is not initialized. Okay, if you go there, if you double click on that, you will see that it's exactly the constructor over here that did not initialize the attributes points. Okay, you get the idea, right? This will be very useful for you to remember when you do the lab test. Because in the lab test, if you forgot to initialize the attributes, you definitely will get a compilation error. Okay, I would say keep that in mind. Okay. Questions about the first one? Okay, it's rather easy. I think the next two is very similar. I'll highlight that very quickly. Okay, the second one over there, we do have the initialization for the constructor. Okay, that was no problem. However, you can see that we're trying to say at some point, we try to assign void to this particular variable p. Okay? You know what? There's a typo. It should be PC. Okay, I'll fix the slides. It should be PC. And now, since you might assign PC to void, in that case, when you try to call this particular feature over here, you will just maybe calling the method or feature on the void target or context object being null. Okay, so that will complain right around this line over here. Okay, it will just say there's compilation error. If you try to see that, I'll show you quickly. If you try to run the sample source code, you will see that the same package there, they will simply say target of the object call might be void, right? Exactly what we said. So we're talking about this particular one, where PC might just be void. Okay, yes?
Should we make PC detachable?
I would say it's not a very good idea. I would say detachable, that means you go back to the case where you simply have no protection from the compiler. If you simply say detachable, that means you as a programmer, you have to always check if your variable might become void. In that case, you might just run into the same trap as you did in Java, right? Or other languages. Yeah. All right. Yes.
Yeah, can you go to the previous slide?
Sure.
Cool.
The code. Yes, I can go.
Yes. But this one, since PC is non-detachable,
Yeah.
doesn't the compiler let you know?
You mean you talk about line number 6, right? That's the funny part. When I tried this on Eiffel compiler, it seems like if you try to make a direct okay, you're talking about this line over here. Okay. You're talking about over here, right? Where you say PC is something void. I agree with you. PC was declared to be over here, which is non-detachable, right? Because we don't have detachable in front of that. So in theory, we should not be able to assign to it. Somehow it's a design decision by the Eiffel compiler. In this situation, they do not directly complain when you assign the void to it, as long as you don't try to use PC. You can think it this way. This is where you try to reassign PC to void. And over here, line number 7, which is where the compiler complains, this is the first usage of PC that might be void. So basically, the compiler would simply show you the first usage where it might be void. It's different point of source of error for the compilation.
You have line 7, 8, or 9, or all the subsequent lines.
Basically, yes, yeah.
It still show an error if you try to make it void.
Yes, so you will see that when you run the source code, they will show you the PC over here and also the PC over here. They will show you that they are both got the possible errors.
What if the line is random? Let's say the last line was equal to.
You mean over here? So the question was, if I got rid of this particular line, you're right, then the compilation error will go away. Yes.
We got rid of 7, 8.
7, 8, and 9? That's a good question. I haven't really tried. Yeah. Maybe try and then see what happened. Yeah. But the principle is this. If you got some non-detachable objects like PC over here, the compiler will make sure every time you try to make use of PC, either especially to make a feature call or method call on PC, they'll make sure it cannot be void. That's the bottom line. Yeah. Yeah. I would say that's the principle you have to know for the exam. Yeah. All right. Okay, let's go back to the slides. And okay, that will be the example. I will let you go over just direct translation. And remember about the example number 3 that we just started today. You can see that's basically the same. We are reading some input from the user, and to say if the integer is less than 0, is negative, then we may assign that to void. It does not complain right over there, not yet. Okay, so that means when we try to say PC.addPoint, this is where it complains. Okay. Okay, if you try that, okay, you will see. I also made the Java code available to you, so you can also try the Java code. You can really see the difference between the languages. It's interesting language design choice. Okay, so now one more thing before we finish this lecture. Okay, it's quite a straightforward lecture. So let's say it's from voice safety. So remember what we said in the beginning of the class. We said the reason that we are learning about design properly was because it's much less costly to recover from any design errors than if you try to recover errors in the implementation or even after release. Similar idea. If you can recover from the errors right at the compilation stage before you try to run the program, is much more cost effective than if you try to recover from errors once you run the program and you got null pointer exception, right? It's much more costly if you try to recover from the runtime, okay? The same idea. Another analogy would be you rather have a voice safety sign for an airplane rather than hoping that, oh yeah, I must be disciplined enough, so I shouldn't really crash the airplane at the runtime. No, you better let the compiler check for you. I think that there's definitely some aviation software that will do, they'll have their internal maybe compiler or some analysis tool to make sure there's no null pointer exception, okay? Yeah, so just different, same idea but different mechanism of making sure there's no null pointer exception. Okay, so now, this is my hope for everybody. So now, let's say after this course, if you don't program in Eiffel again, most likely, in that case, if you're really used to and appreciate the idea about voice safety, and when you go back, this is what I hope you will do, okay? Make sure that you always try to initialize the attributes and also try to make sure whenever you try to make a method call, make sure the target is not void or null, okay? That's kind of the thing we want to have. Because you wouldn't have that kind of safety net from the compiler anymore if you go outside the Eiffel compiler. Okay, any questions about voice safety? Okay, yeah, as I said, it's not difficult subjects. Okay, hopefully you got the idea. Yeah, if you're interested in other references, please feel free to go on to explore. Okay, okay, are we ready for another topic? Okay, good. Let's talk about Mathmodels. And you might have been curious about what Mathmodels is, right? Since for lab 3, I asked you if you want to work on your home machine, you got to set up the path for the Mathmodels. And what Mathmodel really is for you to actually create some abstraction for your implementation. So it's actually very good for you to write your contracts. So that's something we're going to talk about for this lecture. Questions?
You mean we could use this for lab 5?
Yes. Lab 5, you'll be required to use the Mathmodels.
Oh, okay.
All right. Yeah, lab number 5. But I'll make it straightforward, hopefully. But you will see the project first, next Wednesday. Okay, you will see the project first. All right, let's now review a little bit of what we said before the midterm. We'll talk about complete contracts, right? Can anybody, without I show you the slides, tell me what complete contract really are? Let's say I have a command. How about this? Let's say I have a class with maybe many attributes over there, and then now I'm trying to define a command or a mutator for this particular class, which means it might change something, it might change something else, all right? How can I know if a contract is complete, especially for post condition? Anybody want to try? Want to try? Well, if I got 5 attributes, what does that mean? Yeah, exactly. That's very good. Okay, so basically what William said was, if you got as many attributes as you like, you want to make sure whatever attribute that are supposed to be changed, you say in the post condition explicitly they should be changed this way. For others, they should remain unchanged. Specifically, what if your attribute is of type composite type, let's say linked list or array, that you would say maybe for this particular region or portion of the array should be changed, but the remaining part should be unchanged, right? That's why we use a deep twin and also stuff like that. Okay, that's what we learned before. And today we'll go a little bit further from that, but we'll see some motivating problem. Okay, that's exactly what we learned before. So you can use the old keyword. Okay, everything we learned before will still be applicable. Okay, intended change is there, and also the rest of the structure is unchanged. Okay, so now let's use a very simple example, the last in first out stack that you learned either from 2011 or 2030. Okay, it's easy enough to appreciate the idea. Okay, now let's see how we can do that. Let's say we want to implement the LIFO stack. We want to give, for us as a supplier, we want to give us some flexibility about how we should choose a strategy for implementing a LIFO stack. Okay? Let's say we got 3 possible strategies. Okay? 3. So we got different features for the stack. Remember, we got push, we got pop, we got count. Let's say these are the 3 features we want to focus on for the stack. And let's say we got 2 possible data structure we might use for implementing a stack. It can be either an array or it can be a linked list. In the case of the linked list, we want to subdivide into 2 different strategies. So we got 3 in total. Okay? What I want to show you eventually, first of all, is to show you how the code looks like, and then we can do some contracts together just as a review. And then we'll criticize on that. And that will be the motivating scenario for Mathmodels. Okay? So now let's say this. How do we implement the size of the stack? For all the 3 strategies, it will be very easy. Let's say you got a attribute called imp. Imp can be of type array. It can be of type linked list. You just call the count feature. So that one is not so tricky. That one is the same. So now the next one would be, how do we determine the top of the stack, right? Let's say the following, okay? For our discussion, to get the top of the stack, I'll give you some illustration right away, okay? Let's say for the case of the array, we say always the last element in the array is the top, okay? Now for the linked list, let's say we got 2 possibilities. Either the first one, we say the first element in the linked list should be the top, okay? And on the other hand, the third one, the last one in the linked list should be the top. Okay, let's just make sure you really understand this completely, otherwise you will get lost for the whole discussion. So what I will do is I'll add a page to iPad and then I'll show you. Basically, we got 3 strategies over here. Let's say we consider a very simple stack abstractly. Let's say we want to, first of all, push Alan into it, and then Mark, and then Tom. Okay, abstractly, this is the stack we are trying to implement. Okay, we got 3 different strategies. Strategy number 1, we're going to use an array. So in this case, in the array, when we after adding Alan, which will be the first one, we got Alan over here, right? And now, since for strategy number 1, the last elements for the array should be the top. That means after adding Mark, we should add Mark to the right of Alan, right? Okay, very good. Okay, that will be Mark. Okay, similarly, after Tom, it will be Tom. That means here is the top of the stack. Okay, the first one is very easy. Now, what about the second one? Strategy number 2 is going to be a linked list. But now, for the strategy number 2, we say that the first one is going to be the stack. Okay? That means when we insert into the linked list, we don't insert at the end. We insert as the first element. So what do I mean by that? That's something like this. Let's say we try to do Alan first. Okay? So that means we get Alan here, over here. Alan. Okay? Now, what about when we do Mark? Should we insert to the left or to the right? Left, right? Because now we want the first one. We want the first one to be the top. Okay, that means after Mark, what we will get is, let me just have a chain over here. Okay, just for simplicity. Let's say doubly linked list. Okay, and then this will be Mark, and then after Tom, we will get something like this. Sorry, let me just draw again. Okay, that's what we will get. Okay, this is Tom. Okay, like that. And apparently, this is the top. Okay, so far so good? Now, strategy number 3 is going to be very similar to the array. Okay, I'll just draw that. Okay, strategy number 3, the end of the list will be the stack, will be the top. So that means we got something like this. So we got 1, we got 2, and we got 3. And now we simply got Alan over here, and Mark, and then we have Tom. And this would be the top. Okay, 3 strategies. Okay, they're kind of similar, but they're also not exactly similar. Now, we're going to go over the code very quickly. For the implementation part for the code is trivial. Okay, we don't have to focus too much. What I would like you to think about, maybe even before we see the code, would you think the contracts for all the 3 classes would be the same? Complete contracts. For example, push. how would you specify the complete contract for the push feature? Okay, just think about it. I don't need any answer. Let's see that, okay? I just want you to think about it, okay? Let me say it again, okay? What I want you to think about before we see the code is, let's not worry about the implementation. It's trivial, okay? What we have to worry about is, because the contract will be public to any potential clients, for these 3 different implementations, are they going to have the same view to the clients for the post condition, for example? Intuitively, maybe not, right? Maybe, but do you know exactly how they look different? Think about it. Okay, we'll see. Okay, so now we'll go over strategy 1, 2, and 3. Okay, one by one, and then we'll get an idea. And we'll try to make it a little bit interactive, so you can tell me what the contract should be. Okay, that will be a nice exercise too. All right, so this is exactly the question I just posted to you. Okay, so now strategy number 1. Let's say we hide the implementation over here. That's none. And then strategy number 1, array. And remember for array, the end of this array is the top. Okay. And now we have a constructor, which means we simply make an empty array. And the count of the array should be 0. Okay, that one's easy. Now let's say for push, just force to the end. Now let's try. Okay. In order to make a complete contract, as we said before, the only attribute we have over here is imp. It is composite structured. That means we have to consider 2 cases, right? Whatever we want to change should be changed. The remaining part should be unchanged. What about the change part? What should we do? Okay, you want to go to imp.count, that position there, and make sure that one is really the element we want to change into, right? Yes, but I would say if you actually try these 2, you will actually imply the count should be the same. Yeah. Okay, good. So that one we agree. That one's easy. What about this one, unchanged? Just give me some idea. What should we do over here? Iterate, yeah. Okay, from where to where? From 1 to count minus 1? Count minus 1, right? Yeah, basically what we're trying to say is something like this, okay? Let's say over here you can think about, let's say if Tom was the last element we are trying to add to the stack, to the array. That means we are trying to say, first of all, not only that the last position should be Tom, but also the remaining part, which I will put in orange, this part should be unchanged, right? That's what we know, okay? Basically, we're gonna go over from count from 1 until the current count has been incremented already, so count minus 1. So these are the 2 to check, to make sure they are the same. All right? Do you agree with this? Okay, from 1 to count minus 1. And then we say imp the item will be, remember to use the deep twin, right? That's something you know already, so I don't need to bother you for that. All right, let's do another one. Pop. For pop, we just want to remove the last elements, in which case we can say remove tail. There's a feature like that. Okay, remove the tail. And then, what about change over here? What will be changed? Yeah? Something like that, yes. Change would be, we just say the size is decremented, yeah. What about unchanged? Any idea? Oh, in this case, should we, now let's say we, okay, here you got 2 choices. Either want to use count or old count. But remember, count and old count in this case are different, right? So let's say use count. How about that? Since my solution, I got count. So count would be already decremented, which means in this case, think it this way. Let's say before the pop, we got 3 elements in the stack. Okay, let's say we got 3 elements in the stack before the pop. And now, after the pop, we should only get these 2. That means the count has been decremented from 3 to 2. So now, let's say we only use count. So which part of the array should we check? Which part? Should we go to count minus 1 or go to everything up to count? Up to count, right? Basically, we want to say something like, so now current count will just be 2. That means count up position 1, position 2. This should be the same as old 1. This should be the same as the old 1. Right? Good. Okay, you get the idea. Unchanged should be 1 to count. That's a subtlety, okay? However, that's something you can try to do as an exercise, okay? What if I change the count over here to be odd count? Do you think it's going to be the same? No, I'm saying that, okay, what if let's say the same contract over here, the only thing I change is from count to odd count. I heard null pointer exception. Are you sure? It's count primitive, it's integer, which means over here you don't have to use deep twin.
Yeah, so we don't have to use all. Because, no.
It's primitive, which means you can still get a copy of the old value, right? In this case, that means old count. Let me give you a little bit hints over here. The count would be 2, right? Count in this case would be 2. And when I say old count, 3, right? So what if I put old count over here? No, actually, what? Think about what, exception or contract violation will occur, but what kind of exception? By the way, guys, not necessarily every contract violation is void safety. Not necessarily, right? Huh? Index out of bound exception. Why? Yeah, thinking this way, right? Let's say if I really put old count over here, that means I'm going to go over 1, 2, and 3. But when I go to 3, but the implementation array has been changed to only of size 2, so 3 is going to be out of bound. Okay, everybody comfortable with this? If I put this on the exam, would you be okay? Okay. Huh? Yeah, of course, the correct solution should be old count minus 1. All right, good. Yeah, I can expect something like that in the exam, okay, if I remember to put it. All right, that's about the array part. Okay, now strategy number 1 and strategy number 3 are rather similar because one is about the end of the array, strategy number 3 is about the end of the linked list. They should be very similar. Let's consider strategy number 2, right? For strategy number 2, that was the interesting part, where the top is actually at the front of the linear structure. That's the interesting part, okay? Now, question for you. Do you think, of course, implementation is different, for sure, right? But what about the contracts? Can we simply reuse the contracts? Where are we going to get into trouble? Where? Before I show you the code.
The count would be the last one, but the first making the changes in head.
Yeah, something like that, right? Because thinking this way. So now let's say we want to do a push. Let's say the stack used to be like this. And now when we try to add a new element to the stack, we're adding to the front over here. So that means when we try to write a post condition, we want to say the first position should be Tom. And the remaining part, how do we do the remaining part here? Used to be should be from 1 until count minus 1. Used to be for the array case, right? What about for the linked list case? 2 to the count, right? So this would be 2 to the count. So you can see the way we define the remaining part is different. So this would be 2 to the count. So it's different, okay? Hopefully you get an idea, but we'll see the code, don't worry, okay?
Sorry, just a quick one, Professor.
Yeah.
Are we actually getting around which is the best?
No, we're not. Okay, this is a good question. The question was, are we trying to decide which one is actually a better implementation for stack? No, they're basically the same. What we are trying to really get into is the way we are trying to write contracts based on the implementation attributes in the post condition a good design? That's the question we are answering. Whether or not they're efficient or not, it's not my concern, okay? All right, let's see. Let me just make one more note for you, okay? So now you can see that for this particular case, when we define the concept about remaining part of the stack, it's basically from 1 until count minus 1. Okay, that's what we define. On the other hand, for this particular strategy over here, when we talk about remaining, it changes because the strategy is different. In that case, that'll be from 2 until count. Okay, that's the difference. Okay, so that means the way you're going to address the second post condition in the push will be different. Okay, let's double check with that. All right, what we have is, let's say we got the implementation of type linked list for the strategy number 2. And then we got simply makes an empty list. And now for push, and you can push to the front, okay? And then the change part, what should we do? Is it going to be the same as before? Before we used to say imp at position, imp.count should be G. What about this? That first, or you can say position 1. Exactly, good. Okay. And unchanged? Yeah, I want to say across from 2 to count, right? Everything should be the same as before. However, it should be more complicated than that. I think we deserve to practice this all together. How about that? Okay. Since hopefully none of you have seen the slides, okay, let's practice together. Let me start with you something like this. For this particular strategy, when I say remaining unchanged. Okay, so now, of course, I'm talking about the push feature, which for which I'll get just G. Okay, I'll start you with to say across. Yeah, let's say use count. Since my solution use just count. Okay, let's say across 1 until sorry, not 1. I want to say from 2 until count. Okay, and then as I, let's say it's the index I, right? So now I'm going to use a universal quantification. So now what should I do over here? Let me try the following. What if I say the following? I say something like imp at position I dot item is just the same as, let's say, old. Okay, of course, let me be precise. O imp dot deep twin. And then I can say, sorry, I'm just running out of space, but I'm going to do the bracket here. I dot item. Okay? Basically, I'm just changing this part of the range, but for the part of the body of the for all quantification, I use the same. Is this going to work? It wouldn't work, right? Can you see why? If you think a little bit more carefully for this particular one, if you think about pushing and popping, right? Let's talk about push. If you think about this, let's say talk about this particular example. The old would be something like this. The old would be let's say Mark, I'll say M, Mark followed by Tom, T. Okay, that's the old version, right? And the new version is going to push to the front. And the new version, I'm going to put it side by side. It's going to be, okay, it's getting my way. Okay, just remember that part belongs to there, okay? And then what I can do is, let's say over here, I'm going to have Tom being the new top over here. That's the one we're trying to push, followed by Mark, followed by Alan. Thank you. Now, if I simply follow this guy over here, as you can see, this is the old part, and this is the new part. Is it going to work? Yeah, it's not really working, right? Because, for example, when starting with the value of 2, we are saying that at position 2 over here, it should be the same as the position 2 over here, Tom and Mark. No, not really. I'm supposed to compare this mark over here with the mark over here. Because we are really trying to push, that means there's one position difference between the old and the new. Okay? So that means when you are trying to run over the old one from 2 to 3, right? That means if I talk about position 2, I'm really talking about position 1 in the old one. That means I should always subtract 1. Get the idea? Okay? Before I take your question, okay? That means 1 and 2. So 2 should be corresponding to 1, 3 should be corresponding to 2, okay? That's kind of the very implementation specific strategy that we have to look after. Let me just show you the code and I'll take questions. Now, think about this. If you are the clients, I just want to use a stack, but you're showing me this. Do I have to care about this kind of very subtlety about how things should really go, right? I shouldn't really care, but somehow it's appearing here. That's a potential problem there. Questions? Huh? So oh yeah, but that's exactly what we did, right? So basically you just say -1 over there, right? 2 to count. Okay. Alrighty. Okay, guys. Any other questions about this? Okay. So push and yeah, and pop is something similar. Yeah. Yes. Question.
Can we go back to the iPad?
Yes, we may. Yep.
For the old one, we inserted at the beginning of the list, right?
Yep.
And so basically our old is Mark and then is it Tom?
Oh, I'm so sorry.
Yeah.
So this should be Alan. You're right. This should be Alan, right? This should be Alan. Thank you. Yes. Can you across backwards? That's an interesting question. Can you across backward? You know what? I'm not too sure. Basically, you're asking, for example, can I say across something like maybe from 10 down to 3, for example, right? That's what you're asking. I'm not too sure. Give it a try and let me know.
If that's true, then we can create a variable that holds the end and star.
Yeah, you may. I'm just saying that what I presented is just one possible solution, right? Yeah, if I want to, but actually I got a feeling that you may not be able to cross backwards. I got a feeling, but you can double check. Yeah, questions?
On the code, we don't subtract.
Did we not? Maybe I think we should. It could be just a typo over there. I think we should. I think we should. I think we should. Yeah, I'll try to fix that. Yeah. But as we try to discuss on the iPad, we should subtract 1. Yeah. All right, and then for the pop, it's just same idea. Now we just do +1. Okay. Okay, guys, any more questions for this? Okay. So now strategy number 3 is going to be very similar to strategy number 1, because now for strategy number 3, okay, you remember that we simply just do the top at the very end of the list, right? So it's going to be very similar. Okay. So now let's not worry about it. So we'll just show you over here. So the change is going to be the last one, okay? And then the unchanged is going to be from 1 until count -1. And then from for the pop, just as the same as before, okay? Like that. Okay, any question about how we write a contract differently for between the 3 strategies? Are we okay? Okay, good. So let's criticize about this, okay? Let's criticize. What I will do is I'll switch to a page where we got all the 3, okay? So now what I want you to do is let's be more focused. I want you to look at, for example, let's look at the push feature and especially for the unchanged over here, unchanged over here, and unchanged over here for the 3 strategies. Okay? Let's think about these 3. Let's think about stuff like this. Remember, well, I can give you at least 2 criteria to judge. Let's discuss individually, okay? One is about information hiding. So basically, every time if you're given a design, if you want to criticize on that, doesn't really mean you want to say it's a bad one. Even if you want to justify it's a good one, you have to use a criteria that we talk about. So far we talk about information hiding, we talk about single choice principle, and also we talk about open close principle, right? I would say let's talk about only 2 for this time. Information hiding and single choice principle. Okay? Now, anyone want to try? Do these 3 strategies all together, of course we might switch between either one of them, right? That's the idea. So we got 3 different alternatives. Do these 3 things together satisfy the information hiding principle? That's okay. That's all right. Do they satisfy the information hiding? No? Okay. No or yes? No. Why not? Well, information. Well, not right to the point. Not right to the point. Anyone want to try? Yeah. Private. That's true. So violation number 1 for information hiding, since we declare the imp attribute to be exported to none, which means it's private, so we shouldn't really mention that in the post condition, right? That's number one. Another one, information hiding. Actually, the second, okay, let me put it down. Okay, so we keep track of what we just said. So number one over here for information hiding. So number one, because the imp is private or exported to none, but actually it is mentioned in the post condition. That's number one. There's another criticism which we can also apply the information hiding principle, another one, okay? Which can also be connected to single choice principle. Yeah, go ahead.
I think we disclose the inner structure to the client.
Okay, we disclose the inner structure to the clients. Sure, that's true. So what? So what's going to be the bad consequence of that?
So the client code maybe rely on
Yeah, the client's code may be relying on one of the versions. For example, let's say the current client is relying on this particular strategy. Okay, let's say this is the client's, and the client simply got an attribute maybe called stack. Okay, that's the client's. Let's say we have a client over here. Okay, that means the client is relying on this particular strategy where we say count -1, and over here we say either item over here, right? Things like that. And also we got either item over here. Information hiding tells us we as a supplier, we should be able to allow to change for the private attribute from one strategy to another, right? Remember the very first example we talked about when we talk about iterated pattern, the chart example, right? The cart example. We can switch from array into linked list. Let's say we do that over here. Let's say at the moment the supplier is using array as the implementation. What if we switch to the version number 2 using a linked list? That means the client now basically is now forced to be relying on this particular version of the stack, right? Now, has the view for the client been changed? It has, right? For example, you can see over here, item +1, and also imp the first as opposed to imp a position count, right? So these are the changes that the client shouldn't be bothered with when you switch the internal strategy for the implementation. Okay, that's number 2. Okay, so now number 2 is when changing the type of imp, client's view is affected. That's number 2. Okay? Now, so far so good? Okay, so these are the 2 things you should really consider why it violates the information hiding principle. Now let's talk about single choice principle. Okay? Single choice principle is more about for you as a supplier, how do you maintain the code, right? Similar idea. I want to change from this particular strategy, number 1, to another strategy, which is number 2. For me as a supplier, if I go from here to here, so change of strategy. For me as a supplier, single choice principle tells me if I satisfy single choice principle, I should only modify a single place, not multiple places. Now, do I have to modify a single place or multiple places? Multiple, right? For example, you can see, I'll highlight it. You can see I got to change from imp a position count to imp the first. And also here I say either item, but here I got to say either item +1, at least 2 places, right? Again, the stack example is a very simple example. Even that, we already violate these 2 principles, not to mention if you got more complicated example to implement. Okay, so now for the single choice principle over here, so what we have is we violate it because when changing the strategy, the the strategy, multiple places to change in both implementation and contracts. Okay, you can see that not only the contract have been changed, and also the way you implement things, im.force versus im.put front, right? So these are all the multiple places. So you can see the way, even though we can correctly implement all the three different strategies correctly, but you can see from a design point of view, it's quite poor. It violates the single choice principle, violates the information hiding for the following reason, for the reason we just mentioned. Any question about this? Are you comfortable? Again, I'm concerned about if I give you a question like this, are you able to answer? Yes? No? I take silence as yes. All right. Okay, good. What else can I do? All right. Yeah, if you still got trouble, either watch the recording or talk to me after class. All right, I'll try to explain again. Okay, so now that we learned this kind of design by exposing the details about implementation in the post condition is actually quite poor because it violates these two design principles. So what would be the best way? What would be a better way to fix it? Okay. Let me just talk about the brief idea, and then we'll get to the how we can implement that. The idea really is, it would be very nice if we can somehow, let me just highlight for the for the pop feature, for things over here in the post condition, and for things over here in the post condition, and for the things over here in the post condition, if somehow we can have a common objects to refer to specify the contracts, rather than saying array versus linked list or versus different ways of treating the linked list. The solution will be, I'll put it here. So the solution will be have a common object to specify the contracts with. Okay, that's what we would like to actually fix. Okay, that's just an abstract idea. But now, what kind of objects do we want to use? Well, the answer is the objects from Mathmodels. All right. Okay, let's see how we can do that. All right. Now let's see what a math model is. Remember we learned about set relation function in 1090 or 1019, right? That's what a math model is about. Okay. Yes.
You're saying that math model is an object?
No, no. Math models are basically a library of classes. For each class, like a relation, set, and function, you can instantiate objects at the runtime. So basically, what we're going to see, for example, in the case of the stack, we're going to use a particular class in the math models called sequence, mathematical sequence. And then we're going to use a mathematical sequence to somehow add something on top of the stack. And then we're going to hide everything else. So in the contract, we only mention about sequence, nothing else. I will see how to do that. So what does that mean? That means since we're going to use the same sequence idea for the LIFO stack, when we switch from implementation to implementation, we don't have to change the way we write the contracts. So all the information hiding principle and single trace principle will be satisfied. That's a big idea. But let's see exactly how we do that. Otherwise, it's a bit vague. Okay, so now, let's now go on to there. Okay, so this is exactly what I talk about how the design that we have currently violates the single choice principle and information hiding, right? Exactly what we have discussed. So I don't need to repeat that. So now, math models. Let me give you some very quick idea about what math model is. Before we talk about the big idea, let's see how we can use it. Okay, very simple. Number one principle you have to remember for math models, okay? For math model, there are two types of features you can use. One is called commands, the other one is called query. By the way, what's the difference between command and query?
Query could be accessors and command could be mutator.
Exactly, yeah. Query is like an accessor and command is like a mutator. Very good, okay? I wouldn't mind if you just say mutator, accessor. I don't mind, okay? Command versus query. Okay, so now basically the idea is we're going to use the math models library to create mathematical objects. So there are three classes we got to worry about for this course. So for this particular lecture we'll see about how to use a sequence. And possibly for your lab, I'm going to let you practice how to use relation. Okay? And then for the exam, you have to know all the three. Okay? Hopefully the lab will properly prepare you for the exam. Okay? Let's see how we can use this. What I would do is, I will simply just go to the iPad. So we got two fragments of code over here. Let's see how to understand it, and then we'll do some examples. Okay? Basically, the way we're going to do this is we're going to add one single attribute. We're going to add one single query to our stack class. Okay? So we still got our LIFO stack over here, and let's say we talk about strategy number 3. Okay? And then we got implementation being a linked list of G. Okay? So our stack is completely generic. Okay? And now what we have is we're adding a new query over here called model. Okay? And then the model is of type sequence. And sequence is just one of the classes from the math model. Okay? So now, over here, the body of the model is going to tell us how we can go from imp into the sequence. Okay? So model, I'll explain the big idea in just a moment. Let's just follow the code. So model query tells me how to convert from the imp to the sequence. Okay? Just like that. Okay? Apparently, if you want to do the conversion, you would just have to know what feature to call on the sequence. Okay? The sequence is a little bit like a string. String is like a sequence of characters. So what can you do to a string? You can append, you can prepend, or you can do other things, right? You can definitely look up the for API later. But let's focus on the ones I want to show you. So what we can do is, first of all, we can say, so now you can see that because the return value is of type sequence of G, right? That means the result over here is of type sequence. Agree? Okay, that's what we learned up to now. The first line over here, we can simply say create the sequence return value to be just empty to begin with. And then we say that we're going to have a loop over here across the implementation. In this case, is simply a linked list. Across the link, remember every collection class is iterable, right? So we say across the linked list using a cursor, and we keep appending to this particular sequence. Okay? For example, let's say over here, let's say if currently we got an imp that looks like this. Let's say imp is pointing to some linked list, and we talk about strategy number 3. Okay? Strategy number 3, where the top is simply at the end. Okay, let's say we talk about that. Let's see what's going to happen. So now again, we're going to have Alan, Mark, and Tom. So the first one is going to be Alan, and the second one is going to be Mark, and the third one is going to be Tom. That's our implementation, right? And we know that this is going to be the top. That's our implementation. Okay? So now the idea is we're going to create another object of type sequence. And the sequence is going to be converted from this particular implementation. Okay? And the way we do that is by going over from left to right and then append that in each time, right? So append over here is simply just a command. Okay, let's do that very quickly. So that means if I try to do this for the very first iteration for this across over here, I would say over here the result is simply just pointing to some sequence object, right? For the very first iteration, I'm going to say result initially just empty. Initially just empty, like that. For the first iteration, you're going to append cursor the item. You can think about cursor is initially pointing to the first element for the linked list, right? So it's going to append Alan into it. Okay, that's the first iteration. The second iteration, cursor is now going to point to Mark. And then we just append. Append simply means change that sequence directly, right? And then we're going to append. So we got another one called mark. You can see I try to draw that a little bit differently. One is linked structure, the other one is not. Okay. And then the third iteration, the last one, cursor will be pointing to just Tom. And then we're just adding another one, Tom. So far so good? Okay. So now you can see that we got the blue one and the green one. The blue one is going to be completely hidden from the clients, including the implementation and also in the post condition. That's where the improvement is going to occur. But the green one over here, which is a sequence, we're going to use the sequence to write the contracts throughout the class. Okay? And we're going to apply the same principle for all the 3 possible implementations. And we're going to see that the way you're going to write the green one for the contracts will be just the same. So we will satisfy this information hiding principle and also the single choice principle. Let's see. Okay, my concern is, are you okay with this particular block of code? Just by defining the query for model, which is converting from a linked list into a sequence. That's all we are doing. Are we okay with this? Questions? Yes.
We translated this for every collectible data type.
Yes. Now, let me give you a little bit preview. Okay, you can see that over here, for this particular implementation here, the top is going to be at the end, right? And now, what about for the result over here? Where will be the top at the end? Also here, right? Now, question for you is a anticipation. If you look back to strategy number 2 over here, strategy number 2 is where the linked list has its the front to be the top. If I simply just try to use the same block of code over here to do the conversion from the linked list into the sequence, would I get the same sequence object like this? I will get a reverse order, right? Agree? If I can somehow do some massaging just in the hidden part, the implementation over here for the conversion to say, whatever conversion I make, I want to make sure the green part, which is going to be shared by the clients, always has the top at the end. If I can do that, that means I can write the contract consistently using the green part. Yes?
So this means you have to change the sequence object based on the top and the top?
Yes, somehow, no. Good question. The question was, when do we have to change the sequence objects? The answer is, you only change the sequence object for the model feature over here. Okay? It has a special name called abstraction function, but I'll talk about that name in just a moment. Okay? So now here's the bottom line. The only place you have to call some command to modify the sequence objects is when you try to do the conversion over here from your implementation attributes, doesn't matter which strategy you're following, to the sequence. Now here's a trick. Because we know, depending on which implementation I'm talking about, it could be the top can be at the front or it could be at the end. However, I want the conversion to do the trick. The conversion part is completely hidden from the clients. But I want to make sure when the green part, the sequence is presented to the clients, always the end of the sequence is the top. Okay? Can you just predict what's going to happen? I'll show you the code for sure. Okay? If I want to do, so you can see at the moment, this is strategy number 3, right? What should I do in order to convert this particular linked list where the front is the top into a sequence such that the end is still the top? What should I do? Which part should I change? Append, right? Okay, you can, well, this should be rather easy, right? I'm trying to go very slowly so you follow the critical logic. So basically, if I try to convert the linked list in strategy number 2 into a sequence so that the last part of the public sequence is still the pop, all I got to do is to use prepend. Right? So that means whatever conversion trick I do is up to me as a supplier, and the client don't have to be aware of that. Right? And since the green part is always consistently presented to the clients, contract will just be the same. Okay, that's a big idea, but we'll get to a little bit more details. Yeah. How does the Eiffel compiler know about? You know what? Don't think a little bit overthink. You can think about model over here is simply just a query, right? simply means the model itself simply just always will take imp as an internal input and then return something that's a sequence. That's all it does. So it's just a normal programming exercise. Yeah, questions?
But when you push, if I push something,
Yeah.
is it pushing onto the linked list or is it pushing onto the sequence?
Good question. If you push something to the stack as before, do you still push into the linked list or you push into the sequence? The answer is it's still push to the linked list or array, whatever the implementation it is. It is when you try to evaluate the contracts for the clients, they will do the evaluation for the model on the fly.
Okay.
So what do I mean by that? It's a very good continuation. Let's go over that quickly. So now I want you to look at this part of the code over here, okay? This part of the code. Let's say we already got our model as a sequence over here, and the conversion is doing this way, depending on which strategy we have. But the only thing we insist is whatever sequence you have over here, doesn't matter what the underlying implementation strategy is. The last element for the sequence in the public view must be the top. That's what we insist. But now I want you to look at this put feature here, push feature here. Have a look at what we're writing here, okay? Are we referring to the imp? No. So information hiding is already partially satisfied. We are not talking about anything that's private, okay? And back to your question there, the implementation part, which I kind of omitted over here, the implementation part should still be adding something to the linked list or to the array. No problem, okay? If you look at the ensure post condition over here, we got, how many mentions do we have for the model? We have, let me just mention that, highlighted. We got one mention over here and one mention here. Every mention of the model corresponds to a fresh call to the query. Okay, that means when we get to this point, for example, when we get to this point, this will be conversion of the new imp to a sequence. On the other hand, you can see what's the context of calling this particular model. Well, it's more like an old keyword over here, right? That means the model over here, this is a conversion of the old implementation to the sequence. That means rather than getting two versions of the linked list or arrays, we're getting two converted result for the sequence from whatever the underlying implementation is. Guys, follow this? Can we go on with this? Okay. One more thing to say. Now, have a look at this particular feature, appended. Okay. Let me put it this way. That might be easier for you to understand. If I try something like this, ensure over here, right? Can I just put something, okay, let me just put it here. Let me write the following. Just tell me if that will compile or not. Okay. If I simply say ensure model is equal to, let's not worry about the deep twin, okay? Let's say old model dot append. I'm basically just calling this particular feature here, append G. If I replace this particular one with this one over here, all I'm asking, it's definitely not correct, okay? Would it compile even? Would it compile? Well, you might run into such trouble, in the lab test. You better think about it, okay? Why would it not compile? Append is a command, which means you wouldn't return anything. It's more like a void method in Java. Remember what we said before. Every expression you write on the contracts, precondition, postcondition, and class invariant, they must return something. So you can somehow construct a Boolean expression out of it. But now in this case, if you simply say append, it's not going to return anything. Right? So this is not even going to compile. Okay? So this is not even going to compile. Okay, to make it short, so you will see that in the Mathmodels, you got many corresponding features like this. You got something called append, you got something called appended. So this is something called immutable. Can you remind me the time? I just want to make sure I don't run over time. Oh, am I running over time already?
Yeah.
All right, you guys are patient. I appreciate that. Okay, I'll continue with this on Tuesday. Good.